The last section of this first part of chapter 1 that we are going to cover talks about distance and midpoint. Okay. The distance is the length of the segment whose endpoints are 2 points on a coordinate plane. Okay. When we look at just linear distance on a number line, it's relatively easy. We can just say 1, 2, 3. Oh, the distance is 3 units. A more kind of mathematical way, I guess, is we find the absolute value between the difference of the two coordinates here. Okay, -6 minus a -3 is -3. But again, the absolute value makes everything positive, so that matches. Okay, but when we're on a coordinate plane with x and y axes, we kind of have to use a formula that is derived from the Pythagorean theorem. Okay, and we will go more in depth with the Pythagorean theorem second semester. Okay, but what we're going to do, we're going to find the differences between the x coordinates and the y coordinates. All right, so the x coordinate here at M is a -4. And then the x coordinate here at Z is a +3. All right, and here we can see that as well. So we will find the difference between our x coordinates and square them. Okay, we're also going to find the difference between our y coordinates. So the y coordinate here at Z is a +3. And the y coordinate here at M is a -1. All right, and again, you can see that here in our coordinate points that were given. Okay, and what we're actually going to do is we are going to add those, and after we add them, find the square root of everything. Okay, so order of operations, we start with things inside our parentheses. -4 minus 3 is -7. -1 minus 3 is -4. Then we do our exponents. All right. A -7 squared is a +49. -4 squared is a +16. And then lastly, we can finally add those two together. So our exact answer would be the square root of 65 units. All right. These first two examples here. Oh, here, let's go back up here. I will write our distance equation here in orange. So again, what we did is we found the square root of the sum of the squares of the differences. That's a lot of math words. Okay. We find the difference of our x coordinates, square it, find the difference of our y coordinates, square that, add those together, find the square root. Okay. This is a formula that you will have on a test. You don't have to memorize it. Okay. So here, I like to label my points. All right, so again, remember, difference of our x's, and it doesn't matter. Are these the same exact? No, they're not. Sorry. -4 minus 3 squared, so difference of our x's. And since I said -4 to 3, I've got to say 1 minus a -1. -4 minus 3 is -7. 1 minus a negative 1 is 2. A negative 7 squared is a positive 49. 2 squared is 4. So if we were asked for the exact answer, we would say the square root of 53. But our directions here say the approximate. So we're going to give the decimal answer. That'll be about 7.3 units. Okay. Example 2, very similar. Let's find the difference of our x's, and I want to show you we can go the opposite way when we're subtracting from the second point to the first point. 1 minus a negative 3. And then the difference of our y's, we're going to go the same direction. 2 minus 4. One minus a negative 3 is a positive 4. 2 minus 4 is a negative 2. 4 squared is 16. A negative 2 squared is 4. The exact answer would be the square root of 20, but the decimal approximation would make our approximate answer 4.5. All right, this third example, we will just leave it as the exact answer. Okay. Darn computer. All right, and again, it does not matter which point you start with when you try to find the difference, but let's keep it the same. Okay. X2 is 16, X1 is a negative 5. Y2 is a negative 1. Y1 is a 2. So remember, we're subtracting inside the parentheses. 16 minus a negative 5 is 21. Negative 1 minus 2 is negative 3. 21 squared is 441. Negative 3 squared is 9. Okay, so after we have subtracted inside the parentheses, we add after we've squared. Okay, so 441 plus 9 is 450. All right, and then we need to simplify this radical since we want the exact distance. All right, 450 breaks down into 225 times 2. All right, square root of 225 is 15. Square root of 2 is as simplified as it gets, so this is our final answer. Okay. Again, you'll have to pay attention to exact or approximate. That will tell you if we want to round or leave it as a simplified radical. And this equation here, you will not have to memorize, so don't worry about that. Okay? Come on. We got one more thing to talk about. My computer wants to cooperate. And that is the midpoint, okay? The midpoint of a line segment. Midpoint sounds like middle. All right, it is the point that is in the middle of the line segment. It divides a segment into two congruent segments. Okay, it is halfway between the endpoints. And so if I were to ask here, if we were just looking at x coordinates, if I said, hey, what is halfway between, let's say, 6 and 12? All right, you're going to add 6 and 12 and divide it by 2. Okay. So that is how we would find the midpoint in one dimension. Okay. 2 dimensions, again, when we're on the coordinate plane, we're just going to find the middle of the x's, add them, divide by 2. That is the x coordinate of our midpoint. But we're also going to do the same thing with the y's. Where's the middle of the y coordinates? That tells you the y coordinate of our midpoint. Okay. Basically, we're finding the average of our locations on the axes. Okay, and there are 2 kinds of examples you will run into. Okay, when we're working with the coordinate plane, the first one is just straight up find the midpoint. Okay, so our x coordinate, we add our the x coordinates of our endpoints. If my computer would cooperate, that'd be great. So one of our coordinates is 8, the other is a negative 14. Eight plus a negative 14 is a negative 6. So our x coordinate of our midpoint is a negative 3. Okay. Y coordinate of our midpoint, we're going to add our y coordinates. Y coordinates of our endpoints. Negative 6 plus 12 is a positive 6. Divided by 2 is a positive 3. So our final answer, we still want to answer as a coordinate point. We put our x value first, our y value second. Okay. Example 2. Add the x coordinates of our endpoints. Negative 2 plus 8. I'm sorry, plus a negative 8 is a negative 10. Divided by 2 tells me the x coordinate of my midpoint is a negative 5. Y coordinate of my midpoint, we are going to add the y coordinates of my endpoint. 3 plus a negative 9 is negative 6. Divided by 2 is a negative 3. So our midpoint of the line segment connecting these 2 points is at negative 5, negative 3. Okay, the other kinds of examples here, we are given the midpoint. Okay, so this point here is our midpoint. All right, so the x coordinate of our midpoint is negative 1. All right, my other endpoint is here. So I know the x coordinate of one endpoint is 3, but I don't know the other x coordinate. That's what I'm trying to find. Okay, to find that other x coordinate, first I'm going to multiply by 2. That leaves me with just 3 plus my second coordinate, and then subtract 3. Okay. Now I still have to find my y coordinate of my second endpoint. I know the y coordinate of my midpoint is 2. And I know one of the endpoints y coordinates is negative 5. But I don't know the other one. Okay, multiply by 2. I am left with -5 plus y2, and then add 5 to both sides. So my y-coordinate of my other endpoint is 9. My final answer is that. All right, we'll go through this next one. The midpoint is -6, 4, so I know my x-coordinate of my midpoint. All right, one endpoint's x-coordinate is -5. We don't know the other one. Multiply both sides by 2. I am left with -5 plus whatever that other coordinate is. And then I add 5 to both sides. So my x-coordinate of my missing endpoint is -7. The y-coordinate of my midpoint is 4. The y-coordinate of the endpoint that I know is 3. All right, multiply both sides by 2. Nope. 4 times 2 is 8. I'm left with 3 plus y2. My y-coordinate of my missing endpoint is 5, so here's what my final answer looks like. Okay. Now we're going to get into some algebra. All right. So remember, the midpoint divides a segment into two congruent segments. So Q is the midpoint, which means that PQ is congruent to QR. All right. If two segments are congruent, then we know that their lengths are equal. Okay. And since we know that they're equal, we've got two 6 minus 3x's that we need to put together. Okay, remember segment addition, PQ plus QR equals PR. So the two parts equal the whole. All right. Since these are the same, we can actually just say PQ plus PQ, which is why we can then say 2 times that length that we know is equal to the total length of the segment. All right, so 2 times 6 minus 3x is 14x plus 2. All right, we're going to distribute 12 minus 6x equals 14x plus 2. Personally, I'm going to add 6x to both sides, subtract 2. I've got then 10 equals 20x, and then divide both sides by 20. So my x value here is 1/2. Okay, but we're actually asked for the measure of PR. Okay, so all I'm going to do now is put this x value into the expression that represents PR. Okay, 14 times 1/2 is 7, plus another 2 is 9. All right, this last example, we just need to draw our picture. All right, it says that y is the midpoint of xz, which means xy is congruent to yz, so their lengths are equal. All right, that's what we can determine with just that given information. Okay, xy equals 2x minus 3, and yz is 27 minus 4x, okay? And actually, right here, since we are looking for the measure of yz, we won't need the segment addition for this one. All right, since my two segments are equal here, I will set 2x minus 3 equal to 27 minus 4x. I've just substituted those expressions in. I'm going to add 4x to both sides, add 3 to both sides. Okay, 6x is 30. Divide both sides by 6, and I get an x value of 5. Okay, but remember, we're not done. We want the length of yz, so I'm going to put that into 27 minus 4x and substitute my x value in. 4 times 5 is 20, which means that the length of yz is 7.